Okay, I think we can kick off. Yeah, I think we can kick off. I've just had a notification that the chat is disabled. Sophie, maybe if you can have a quick look in that in the background. So in the meantime, good morning and welcome to the Net Zero Technology Centre's Tech20. My name is Sakshi Sarkar and I'm the project engineer for robotics and autonomous systems here at the Net Zero Technology Centre and your host for today. Welcome to our Tech20 series. For those of you who are not familiar, our social showcase for speakers presenting on their technology focused topics in 20 minutes. So we're super delighted to have you all join us on the webinar this morning. Before we kick off, I do have a few housekeeping points. So if I can roll on to the next slide, Igor. So we call these events Tech20 because we have split them into 20-minute blocks. So the first 20 minutes, we will hear from our speaker today. Then the next 20 minutes, we'll have Q&A, and then there'll be 20 minutes for networking. So while Igor will be speaking, your microphone will be automatically muted and your camera is automatically disabled, you will have noticed. For the Q&A function, if you can raise your hand, we will allow you to talk, or if you just want to type in a question in the chat function, you're more than welcome to type in your questions there, and I can facilitate that Q&A when we get to it. So if you are having any connection issues, we do recommend you shut down any non-essential applications. The webinar is being recorded. Please try not to take any snapshots or record the webinar. We will share the recording later anyway. And if you are, I think that's everything. So of course, the last point there, I think everyone will be familiar with online webinars now, so I shouldn't need to say anything more. One request from everyone, if you can type in your name and the company that you are from today in the chat, that would be really nice. And lastly, we want to make this session as engaging as possible for both of you and the speaker. So please do raise your hand if you feel comfortable speaking. In the 20 minutes, we'll get through as many questions as possible. And if we don't get to your question, we'll try and respond to it after the webinar as well. If you comment on any socials, please use the hashtags Tech20 and time to Tech20 as well. So without further ado, let me introduce to you our speaker, Igor Martin, who is the CEO of Hydromea, a Swiss-based company with core experience in underwater robotics. Igor himself has over 15 years of experience in corporate business management, and he is backed by his colleagues Felix Schill and Alex Barr, who Igor may talk about a little bit more, the CTO and CEO of Hydromea with technical experience in real-time systems, aerial underwater robotics, tetherless operations, grouped navigation of AUVs, underwater sensor equipment, and much more. So a very strong team put together indeed. So Igor, over to you. Can you tell us a little bit more about what you're going to talk today?
Yes, thank you, Sakshi. Hello, everyone. So I will try to entertain you with our presentation here today about subsea robotics. Although it's difficult to compete nowadays with entertainment intensity that we get from the politicians. But I hope that you are familiar with the overall subsea robotics subject, and I hope that my pitch will resonate. And certainly note the questions, please, and I'll be looking forward to having a discussion and answering your questions after the pitch here. All right, so the problem that you may be aware that is the industry, the offshore industry has, and the one that we are trying to solve, is that the submerged asset inspections today are highly inefficient. This is one of the images of what actually needs to be done to do IMR, inspection, maintenance, and repair in the offshore space. And today, inspection, maintenance, and repair is roughly similarly divided in terms of what's done, what's I, what's M, what's R. So 60% roughly is done. Is inspection and maintenance. And the industry is trying to take the supply ships off the water and replace the ROVs with AUVs or UIDs. And here are some of the examples of this technology that is being worked on and increasingly being trialed in the North Sea specifically, whether it's a Saipem, Saab, Oceaneering, or Ilum. And there are some others as well that are trying to address this problem as well. And also what we see is that the oil and gas has been giving jobs to service companies for IMR up until now, and will certainly continue to do so. But what we'll see over the next decade is that the offshore wind will be putting significantly more assets in the water that oil and gas has put for the whole lifetime of that industry. And that's also what Carl Troll said in one of his presentations. So the question really is, when we look at oil and gas, but increasingly when we look at offshore wind, how much is I and M need to be done or will be done, and how much R will continue to be done? We know that the assets of offshore wind are less sensitive, let's say. There is an opinion that IMI, especially as we go into predictive maintenance, will actually help reduce the share of R of repair that needed to be done, as long as the asset owner has a better picture of the condition of the assets underwater. Another question is it really necessary to put multi-million-dollar vehicles to do the I and to do the M? Can this be done with less expensive, more affordable systems? And what's going on right now, as you may certainly be witnesses to, is the industry is developing technologies in smaller and smaller form factors. So today still it's difficult to imagine to put all this great tech on a small vehicle. You do need a larger system just to support the weight and the size of many subsea technologies. But we also see that more and more companies, sensor companies, visual inspection companies, are coming up with technologies that are significantly lighter, smaller, and can do the same job pretty well. So we, Hydromea, we take inspiration from the nature, and we kind of say, all right, it's true that the big vehicles will have a place in this ecosystem, and they are needed because there are jobs that can only be done by massive AUVs. But there are also opportunities to come in with smaller form factor robotics. So if there are orcas out there, there is also fish that can manage to navigate high currents and depths and so forth. And so that's what we're really trying to go. That's where we're trying to go to with our technology. So a few maybe words about us, where we are coming from, what we do. So we are focusing on automating remote inspections of submerged assets, and we're trying to bring this technology in such a way that is affordable, that is portable, sometimes even maybe almost sacrificial, to really enable more affordable and more repeatable inspections of underwater assets. Hydromea, we have substantial IP in underwater communication, navigation, and we make anything that we make, we will focus on very small form factor. You know, being from Switzerland, the watch country, I guess it's in the DNA that anything you do, you need to put a magnifying glass on. And so we believe that this approach should help the industry reduce the cost of inspections, further eliminate safety risks, provide ad hoc availability of robotic inspection systems, which are easier to bring to a site on a very tight deadline. And as we do all this, we are also helping taking the supply ships off the water and reduce CO2 emissions for the industry. There are fundamental shifts that accelerate adoptions of robotics underwater today. Certainly strong environmental pressure to look at CO2 reductions. Offshore wind is projected to explode, and the economy overall, ocean economy, is also projected to double between 2020 and 2030. And there is also more and more going on now, not just the talk, but also activities in underwater autonomous infrastructure development, notably led by Equinor in the North Sea. So with Hydromea, we've started as a company that was making portable AUVs to collect environmental data in the water column. We thought that if you send a small swarm of submarines, relatively affordable submarines in a delta or in a lake or in a particular perimeter of a sea, this swarm can collect thousands more data points than two people could on a boat. That's how it's done today. And so the resulting activity, resulting output of this activity would be a 3D cloud of whatever it is that you're measuring. So we've built a number of those vehicles, and we've run some scientific campaigns to collect data. And then we went to Aberdeen and spent time with Oil and Gas Technology Center, which is today obviously NetZTC, Net Zero Technology Center. And we learned about the challenges that the offshore industry faces, and we were quite inspired by that. We have actually a pretty good fit for the problems that the industry has, and we started to connect more and more to the offshore energy industry. And so what came out of it is that we believed that we can actually offer a combination of a freedom of an AUV, but control and size of an ROV. So a hybrid system that would be able to travel autonomously to a point, but then could also be taken over by a pilot remotely to do an inspection, to do a certain mission, maybe data harvesting from sensors. And so the vision of Hydromea is that in the future, and this vision comes from many conversations with the operators of offshore energy assets, is that you will have more and more metal on the seafloor that will require monitoring and inspection. And this will increasingly be done by robotics. Big vehicles like Oceaneering and Saab developing, but also small drones. We also take inspiration from what's going on at the ground level. We see emergence of aerial drones. They're ubiquitous today. The kids play with aerial drones. But there are certain challenges underwater that I guess many of the audience today here are aware when it comes to communication, navigation, visibility, pressure, currents, and there hasn't been done that much in the portable robotics space yet, but certainly it's a direction that a number of companies are taking. And so at Hydromea, we've discussed a roadmap. How can we actually bring this technology to the subsea space? It is a complex technology. It takes time to de-risk certain elements of it for subsea, for a very harsh environment such as subsea. And so with Net Zero Technology Center, we've brainstormed and laid out this map that we believe we can deliver on. And the map is broken into 4 steps. The first step that was co-founded also by Net Zero Technology Center is at its finale right now. with the first step, what we've been doing is we are enabling wireless control and command of a portable drone next to the assets to do GVI, a visual inspection, to harvest the data from the sensors. As we were developing this, we also came up with a confined space inspection vehicle, a couple of slides on which I will show you a bit later. The next step in our roadmap would be to connect this to an AUV vehicle that would be able to travel from a drop-off point on the top side, on the water surface, go to the target, to say a template or a power station underwater, connect to the control room, so that the control room could update the mission, send this AUV on a short mission, check in, check out, and then send it back to where it was dropped off. The third stage of our roadmap includes persistent residency of such system. So you don't have to rely anymore on dropping it from, say, USV or aerial drone. It can actually reside on the seafloor. Again, something that bigger companies do already today, starting to do today, but why not miniaturize this as well? And then the final step is we will bring our expertise in swarm robotics and make this kind of solve a collaboration challenge of various agents underwater. And by swarming, we don't just mean that there will be 5 or 10 vehicles that talk to each other. A template, a monopile, any structure underwater can also become an agent in this swarming system. So that's the vision that we have, and we believe that we've got good baseline to develop this project forward over the next several years. And sorry, there is some music as well you can hear, but I'm sharing with you a video that we just compiled relatively recently. We did a pilot with Total Energies in September as part of this project, as part of the first phase of the roadmap, where we're showing an ROV that consists of 2 vehicles. One vehicle is tethered, so let's say your traditional ROV, but then you have another vehicle that is, we call it daughter, that can be launched into its own wireless campaign. And the second vehicle that is wireless, you can see that there now, the daughter is unleashing from the mother. And then the daughter has full control of a pilot on the top side. We use a technology we call Luma. This is a free space optic technology that is particularly suited for this type of a task. It's low latency, high speed, high bandwidth communication that provides a pilot with exactly the same experience from a wireless drone as if he or she would have from a tethered drone. So you have a base, a tethered base in a tank like this that is communicating to the wireless drone, and you basically, pilot takes over the wireless drone and does the inspection as they need to. That certainly helps in those spaces where you have a lot of furniture, complex spaces where the risk of tether entanglement is relatively high. You could use this wireless drone to get into a specific, very difficult areas. It's not constrained by tether. It's got 6 degrees of freedom. It could turn anyway. So for instance, here, the wireless drone takes a UT measurement, the metal thickness measurement, completely vertically. So this goes, I guess, a step further from what ROV technology today allows you to do in confined spaces. But again, the idea here is not just develop a new vehicle for confined space inspections, which is one outcome of this step. The idea here is really to show that you could have a wireless vehicle coming next to an asset underwater and being taken over completely by a pilot that would be sitting safely on shore, and then command control this vehicle, get real-time video, get real-time data, offload, and then could ask a vehicle, could either control vehicle to do a certain inspection, or could ask a vehicle load up a mission to do a small autonomous inspection of the surroundings, and then come back and report back to show the quality of the collected data. So this video is just about to finish, and there are a couple of more slides that I will show you that basically has some of the technology that allows this to do. So this slide just shows you the quality of the video. Of course, today video cameras have gone in a have pretty good quality. So this is a HD video that you see, but it's also possible to take 4K shots if you need the images of high quality being collected during the inspection regime. We also already have 8 cameras, 4 front-facing cameras for quadroscopy, and then 4 sideways cameras for peripheric vision. And that allows us to collect data as we do deployments already today to enable sense of the distance from a particular asset, provide global situational awareness. It will work as obstacle avoidance and help with positioning and station keeping. And of course, yes, it is developed for relatively clean water environments. Visual will only work as long as there is visibility in the water. The next step that we are working on is adding sonar to the system so that it can also in the future work in relatively turbid waters of the North Sea. So it's not just the visual that we'll be relying on, it's of course also sonar data. So part of the system that enables this is, as I mentioned already before, free space optics. Hydromea has been developing optical communication technology to connect point A to point B wirelessly underwater for a number of years. And in fact, we now have a line of products that you can just send us an order and you can get it in a 10-week time. One of the key applications, use cases for this technology, and this is the courtesy of Equinor, the vision that they have, is that you have acoustical communication around your infrastructure, which is here shown by green bubbles. But optical communication gives you this Wi-Fi capability to connect to your control room with high bandwidth link, and this is represented here with blue bubbles around templates. So you can imagine that if you install FSO, free space optics modems, like your Wi-Fi router at home, you would be able to then have this high-speed communication within that limited range around the asset that you have. It's very similar to your Wi-Fi at home. As long as you are in your office or at home, you can stream Netflix, you can have video calls, but the moment you step out of your house, you will lose that connection. It's the same logic here. And I won't spend much time talking about what optics is versus acoustics, but there are 2 key. Acoustics is really good technology, of course, for the range. It works really well and being deployed for forever now. The big advantage of optical communication is that it's significantly faster, and because it's faster, it can send much more data in a very, very small period of time, and so the energy efficiency, say per byte or per bit, is quite high. So yeah, if anybody interested in our technology, there's a little bit advertising here, please get in touch with us. We certainly are working on some exciting projects connected to this technology. So this is all for me to give you a rough idea of what we believe in, where we are going. And we certainly look for partnership opportunities. If anything that I said today resonates with you and with plans that you may have, or if there's anything we can help you with, please reach out. We'd be happy to certainly entertain that conversation. Thank you very much, and now I'm passing on back to Sakshi.
Thank you so much, Igor. I think I can say on behalf of everyone here, it was super interesting and really nice to see, I guess, the vision that you have and how it fits into the sort of the North Sea offshore energy sector. As I see, there's a few questions that have been dropped in. So I'll start with the one in the chat from John Murray from Abyss Solutions. So it's kind of in offshore wind in mind. So in the case of offshore wind, do you see an opportunity to use your experience with environmental survey to inspect, monitor the impact of subsea structures in the subsea environment, and then comment on the condition of the structures themselves as well?
Certainly, we do see an opportunity to do that. It's actually in a separate, in different stages of the wind offshore park. It's when you do the initial assessment of the grounds, and when you do construction, and when you are in service. So yes, we certainly are looking forward to apply our expertise and specifically bring swarming in this context to the offshore wind industry. It's not going to happen immediately. There need to be certain steps taken, but again, back to my roadmap that I shared. That's certainly within the realm of possibilities that we will be doing.
Excellent. So another question from the Q&A box was around, you talked about I guess the visibility challenges in the North Sea environment, because I guess FPSO tank inspection that was done was quite like a stable environment. And you mentioned the plans to use sonar technology, I assume more for navigation purposes, but in terms of gaining that the visual inspection or the visual inspection capability, what do you see as a key challenge to overcome for the North Sea area?
I think we see great examples of technologies that are already being commercialized and used. One would be the great stereo camera that that has put out and is being used today. Sorry, I forgot the name, but I guess you know what I'm talking about. That's the company that ORE Catapult is talking about quite a lot. So yes, there are technologies out there. The challenge for us, I think, is to find a way to make this technology smaller so that it could be put on a smaller form factor vehicle, that would make sense to bring this technology to a site. So it's not so much, I guess, the problem of that the technology isn't there. It's just technology isn't yet suited to be onboarded on a low form factor vehicle today. So we do have some ideas how to go about this, and we are connected to a couple of research institutes that are actually trying to address this same topic. So we are quite hopeful that it's going to be possible. And again, we're not talking about that we need it immediately today, but in the 3 to 5 years, I would expect that that's quite feasible to imagine that it's going to be possible.
Yeah, I guess it's part of that roadmap of developments, right? And then being open to collaboration and kind of integrating technology that's already being developed or accessible to try and accelerate that.
That's right.
The full system. Brilliant. So I've got a couple more questions from Mark Anderson from our TechX program. So Mark says, absolutely fantastic presentation. So the first question is on the sort of dimensions the X-ray can go to. So how small can it go, I guess, is the question.
All right. Well, the current vehicle is 13 centimeters high, I think 48 centimeters long, and 38 centimeter wide. When you put two vehicles together, basically the height goes to obviously 26 plus docking, and you also have a payload, so you could add a gripper, you could add a duty sensor, and we are looking at more payloads that this system can take. So yeah, our focus is really to try to make it as small as possible. There are certain constraints on endurance. So how long will the vehicle need to stay to be interesting to the clients in the water, and of course that dictates how many battery cells we need to put in. Other constraints, of course, specifically for confined spaces, is that the vehicle needs to get into tight manholes, and our limit that we put ourselves is to always be able to go into a 40 centimeter manhole.
Mm-hmm.
So yeah, and we do have ideas. We see some interesting opportunities how to further reduce the size and make maybe a small miniature babies that could go off the mother, and in a relay could actually even go around many corners. So like sort of like a snake, but the snake connected through optical communication. It's yeah, right now it's already small enough, but we could actually make it even further.
That's really exciting. Yeah, it sounds really interesting. And I guess, yeah, it's like the true swarm robotics stuff. Another question from Mark was, what excites you most about the next few years with respect to your technology development?
Good question. Many things excite us. It's difficult when you go to the market and talk about technology development when you have not much to show. When you show CGI, movies, animations, people kind of get excited about this, but very quickly they say, "Okay, that's nice, but show me what you can do." So with the help of NZTC, we are extremely excited to be able to bring this robot now to trials and to show the industry that, look, we showed you a CGI movie in 2021, but here at the end of 2022, this is the vehicle, this is what it can do. We got a lot of already feedback on the video that you saw today, that it looks like a sci-fi movie. And it certainly does, even to ourselves. We are extremely proud to be able to deliver this and show this. And we see increasing interest from a number of industrial partners to take and trial this technology. So we're excited about getting this edge in robotics to let the clients do more. And be at the cutting edge of innovation. We filed a few patents already, and we have some other ideas how to differentiate ourselves further. But with that, of course, also it is critical that we do have support of the industry. Without support of the industry, we wouldn't be doing it just on our own by ourselves. So we are excited about the reception of this technology, and we look forward to even more partnerships with operators from the offshore energy side.
So on that, we've got another question in the Q&A just before that one. So on the area around collaborating or partnering with the operators in the offshore energy industry, are there, I guess your experience so far, are there any challenges that you see that the industry needs to overcome or developers need to overcome, or something more that NZTC can facilitate with, or what is your kind of key thoughts on that front?
We see that offshore oil and gas companies in oil and gas that operate offshore are quite interested in this technology, and they invest in this technology, which is fantastic. We are a little bit concerned that the offshore wind industry is, while talking about importance of that, is not yet seen to really having a strategy on how to support this type of developments, this type of technology. It's certainly not their headache today, and they are very open about this, but it will become their headache in the next 5 years or so. increasingly. And so if the industry is not supporting robotic companies today, in 5 years' time, it may find itself that it needs to catch up. So we certainly talk with NZTC a lot about who could come in and support, who would be interested to join on the roadmap. We do have already two offshore players from the industry supporting on this roadmap. But we are looking increasingly to also open up this discussion with offshore wind farm operator and really understand when they're looking at this, how they're looking at this, what we need to do today, so that in 5 years' time we are more fit to do what they need to be done around their assets.
Yeah, so definitely a really good point, because this opportunity now to get ahead of the game with the renewable side of the industry as we grow our, I guess, the production capability on that front and grow the assets and the infrastructure on that front to get them ready for more automation or the use of robotics in the way that they operate as well. So definitely a great point to make. So the question from Alice Pease from NZTC is, so one comment as well, it was the video capability is incredibly clear from the kind of the images and the videos that you showed, which I think is absolutely fantastic as well. So there's two questions. What is the status priority of testing in highly turbulent waters? And then the second question is, are miniature autonomous robots inside well bores themselves on the radar for Hydromea for the purposes of inspection inside wells or hydrates detection and other use cases?
So our current focus is on confined spaces with relatively calm waters, and that's because you want to really de-risk the system in the controlled environment, and we do see opportunities already, use cases in this area. The highly turbulent waters, we do have a client who has highly turbulent waters and who is very interested to test the system. So we will be testing it soon, maybe either at the very end of this year or beginning of next. And we haven't tried it yet ourselves. So we are interested, we're intrigued about what potential limitations that we can face, and then whether we could find a way to work in this environment. So my honest answer is that we don't know right now. Once we see how the environment is and what happens to the, let's say, wireless communication, we don't expect specifically wireless communication to be an issue, because light is light. It just penetrates, and you can think of like if you put a flashlight through any medium, as long as the flashlight can go through that medium, and flashlight goes through air bubbles and water, then our system will work. We use photons to send data from point A to point B, but it just needs to be seen. Regarding the miniaturizing technology further for specific pipe inspections, well bores, we don't have that use case presented to us yet. Yes, indeed, some people spoke about potential opportunities, but we don't have a partner or a customer yet that said, okay, guys, come with me. Let's see. This is my problem. That's what I would like you to do. We're certainly open to this approaches. We have a very high interest from a number of players from the hydropower space who see this technology as groundbreaking, using their words, to get into extremely difficult penstocks and tunnels and do inspections there. So that just extends the possibilities for this technology further. But from the development side, there's still work to be done to get in those type of environments. But it looks likely that that's something that the industry is really keen to support us on as well, in that direction, a little bit from offshore into onshore.
That's fantastic. I think knowing that the technology can have many cross applications is always very, very valuable and interesting to learn about. I think we are almost out of time and we'll be moving on to the networking session. So just before we go on to that part, Igor, can you tell us, I guess, just to summarize, what are the key steps for this X-ray technology in the next 3 to 6 months in the next short term?
Sure. So we are getting ready to our first commercial deployment at the very end of December on one of the FPSOs in the North Sea. We signed up a service partnership agreement with ACE, Air Control Tech, Intech, sorry, which is based in Aberdeen. Really nice group of people, and we have a lot of synergies, we believe, and looks like they do too. So we would like to expand on that relationship. So that's our service arm today in the North Sea, and they will increasingly be using X-ray for inspection of ballast water tanks, and we're looking at some other opportunities there. So for us, the critical piece is to scale it up so that it is in a commercially available. Our target is to make it commercially available as of June of next year. And in the meantime, we're running a lot of pilots, so that's key for us when it comes to the drone technology. And also now we are preparing for the next leg. We do have support already, but we are still, we would be very much excited to get offshore wind operator to maybe join on the roadmap for the reasons that we talked about earlier. So we try to meet with different people from that space to see if that tickles their brain and if they can join us or not.
Excellent. Thank you so much, Igor. So for everyone else here, we will be moving on to our networking session for the last we've got just under 20 minutes left. So if you are staying for the networking session, please stay and we will enable you to unmute and on camera or put your cameras on, and we can have a bit more of a free discussion with Igor, and I will still be here. So yeah, I think we can maybe move on to that part.